All right, welcome back, party people. Today we're going to be talking about tides and eclipses. So, tides have to do with the moon and the Earth's gravitational relationship. And as the moon revolves around the Earth, the tides become high and low. And this is a time-lapse video of a place in Nova Scotia where it's one of the greatest examples of high tide and low tide every single day. So you can expect every 6 hours for the tides to change. 6 hours low, the next 6 hours they're high again, next 6 hours low, next 6 hours high again, and that's kind of what happens every single day. So you can say that every single day there's 2 high tides and 2 low tides. Okay, so that's, wildly testable. Make sure you have that. High tide every 6 hours goes from high to low. So 6, 12, 18, 24. Obviously 24, is divided by 6. 6 times 4 is 24. So you can expect high and low tide, 2 high, 2 low every single day. And this is a great video for that. You can watch that again. Just search up Bay of Fundy. And Nova Scotia is where that's at. So let's talk a little bit about, so now that we have, that there's 2 highs and 2 lows every single day, there's 4 moon phases where the tides are affected the most. Can anybody guess which 4 they are? Come on, think about it. How about new and full and first and third? So in the moon phase video, I talked about how there are 4 main moon phases. So it's new, full, first, and third quarter. Okay, and then there are transitional phases, which are the crescents and the gibbuses. Whether it's waxing when it's going from new to full, or waning when it's going from full to new. So the crescents and gibbuses are transitional stages, last about 6-7 days, and then you have your main phase, which lasts about a day, with new, full, and first quarter and third quarter. So let's talk about what happens during the new and full moon. We call these highs and low tides. We call those spring tides when it lands on those 2 particular days. And the reason why we call them spring tides is because not only, so you have the full and the new moon whenever it lines up, as you can see, it lines up in a straight line. So not only is the gravity from the moon pulling on our ocean's water in that direction, the gravity from the sun is pulling in the same direction. So as the Earth spins and rotates around, those, you have high tides just happening, all over the planet at any given time. But as we know, when think about, let's think about Galveston, for example. If it's 6 a.m., okay, and we're experiencing a low tide, just kind of go with me for a second. 6 a.m. low tide, in about 6 hours, it'll be high tide. And I'm showing you the Earth spinning. 6 more hours, it will be low tide again. 6 hours, high tide, 6 hours, back low tide again, and that's a whole day, okay? So spring tide, when it lines up in a straight line, these are your strongest tides. And this phenomenon happens twice a month during new moon and full moon. Okay? That's when you have your highest highs and lowest lows. There's the greatest variance between high tide and low tide when it lines up like this, new moon, full moon, and that's spring tides. Now let's talk about the opposite, the ones that happen on the first and third quarter, and we call these Neap Tides. And I think of it as Neap is weak. So it's 90-degree angle. It's first and third. Look at the gravitational relationship between the moon and the Earth when it lines up like this when you have first quarter and third quarter. And you can see the gravity from the Earth and the Moon is pulling in this direction here. But you still have the gravitational relationship between the Sun and the Earth, which also pulls this way. So you have it pulling in two different directions. And when you do that, you have more of a balance in your highs and lows. Okay, once again, happens twice a month. It happens during the first quarter and third quarter. And so when I talk about this balance, you're talking about average tides, minor changes between the highs and lows. It's not as drastic when it lines up like a spring tide. Okay, so you can kind of see the differences here between these two slides. Spring tide, straight, strong, 3 S's. Spring straight, strong, straight line, twice a month during new and full. Neap tide, 90-degree, weak tides. Minor changes between the highs and lows. Okay, so a smaller variance during neap tides, greater variance between highs and lows, much more drastic during that time. In fact, you have surfers, you know, in my Hawaii that like to go out and surf during these times the most because the waves will be the strongest during those times of the month. So, little fun fact there. Okay, and that is your information on tides. Feel free to watch this again if you need a little bit more assistance. Now, we're going to go into eclipses. All right. So this only happens when the moon, sun, and earth line up in a straight line, okay? So let's talk about solar eclipse first. The 3 players are the sun, the new moon, and the earth. This makes kind of like a new moon sandwich. As you can see, earth on this side, sun on this side. And so when it lines up in a straight line, it's like an exact straight line from where we are located on earth, you can see an eclipse. And depending on where you're located on Earth, you know, your view might be a partial. Sometimes your view might be a full. It depends. But what happens is the moon passes right in front of where the sun is in the sky as we are kind of rotating around. So that's how an eclipse will happen. If you think back to 2017, right around August, we had our last pretty awesome solar eclipse, and the new moon passed in front of it. I was outside with the staff, and we noticed it got dim really quickly. It got like creepy, eerie outside. It only lasted for about 1.5 minutes, 2 minutes, and then the moon went ahead and continued its transition in front of or past the face of the sun. So that is solar eclipse. Now let's talk about the lunar eclipse. The lunar eclipse is when you have a full moon in the sky, but when it lines up in a straight line, of course, Earth will cast a shadow into space, typically hitting not much, but sometimes the moon passes, the full moon will pass in that shadow, and that's when we get an eclipse of the full moon. And a lot of times we've been calling those blood moons. You know, you can do a little research on blood moons, or it's actually pretty fascinating. But all a lunar eclipse is Earth's shadow is casted on the full moon, darkening it. And depending on where we're at, sometimes it's a partial, sometimes it's a full eclipse of the full moon. And that is it for eclipses and tides, friends. We will see you next time. Boom, I'm out.